Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to track the vehicles with the help of opencv on Raspberry OS Bullseye 64-bit version. Okay, before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, we are going to track the vehicles with the help of opencv. Okay, for that, of course, you need to install the opencv on Raspberry OS Bullseye 64-bit version. Also, you need to install TensorFlow Lite. I have created the both videos how to install opencv and TensorFlow Lite on Raspberry OS Bullseye 64-bit version. I have already installed opencv and TensorFlow Lite. That's it. So now you need to open the link. I will mention the link. It will open the opencv object tracking Bullseye GitHub repository. Inside that we have tracker.py and video download. This is what the text file, and inside that text file we have the video link. Okay, simply go to the code, copy the link, minimize the browser, open terminal, and we are going to run the command sudo git clone and paste link and just hit enter. Okay, it will clone our repository. If I run the ls command, we have now opencv object tracking Bullseye folder. Simply we need to change the owner, so sudo chown space capital -r chown space capital -r py, and we need to mention our folder name, which is the opencv object tracking Bullseye. That's it. Clear the screen, cd opencv, and our which is our folder name object tracking Bullseye, hit enter. Now we are inside the folder. Okay, so first what we want to do, as I told you, we need to simply download our video. So I'm going to go inside the file manager. This is what our folder, video download, text file, right click, text editor, and this is what the link, the mega cloud link. Copy, open the browser, paste link, and just hit enter. And as you can see, this is what our zip file. Click on download, it will download our zip file. So friends, as you can see, we have downloaded our video.zip file. Now I am going to minimize the browser and close the text file. I need to go inside the downloads. So inside the downloads we have our zip file. Right click, extract here, and as you can see we have our bit.mp4 file. So we need to move the file inside our clone folder, which is opencv object tracking Bullseye. Paste. Okay, so we are all done with download. Simple. Now we are going to open our Thony Python IDE. So programming Thony Python IDE, and we need to create a file. So right now the file is untitled. Simply click on save, and we are going to save the file inside py opencv object tracking Bullseye. This is what our folder, okay, where we have our tracker.py. Also we have our video file. So I'm going to mention the name main.py. You can mention any name. Okay, so simple. So let's start our code. Import cv2, then cap is equal to cv2 dot video capture. Okay, and we need to pass the file, which is read.mp4. that's it, read.mp4. then while loop, while true success frame is equal to cap dot read, and cv2 dot destroy all windows. Okay, so this is what our basic code for reading the video file. Okay, so simply save the code, and if I run the code, and as you can see, this is what our video. Okay, so I'm going to stop the code, and I'm going to run again the code. If you see here, when we start the video, the somehow it's basically the camera is little bit moving. As you can see, the video frame is little bit moving. Okay, so up and down, as you can see. So what we are going to do, we are going to simply skip some frames. Okay, so how to do that? Simply after cap we are going to say like this way, cap dot set and 1, and we are going to skip let's say 390 frames. We need to skip 390 frames. After 390 frames we are going to start our video. Okay, so now as you can see the video is still little bit moving up and down. Okay, so what I am going to do, we are going to say 400 frames, or let's say 450, let's say 400 and let's say 40. Okay, save the code, and if I run the code, it's still little bit moving, so let's make it 450. Okay, now it's okay, so we skip 450 frames. Okay, and after that our video will be start. Okay, now what we are going to do, we are going to also increase the weight key. Let's make it 32. Okay, if I save the code, if I run the code, now it's good, it's okay. Okay, so we are ready, we are all done with our video frame. Okay, simple. Now what we are going to do, we need to select a region of interest area. Okay, so what we are going to do, in from video we need to select a region of interest area. For that we are going to use ROI function, select ROI. Okay, simple. So stop the code, and after capset we need to copy success and frame resize. So copy it, and here we are going to mention like this way. Okay, and then we are going to say ROI. Okay, so ROI is equal to cv2 dot select ROI, and we need to pass our frame, then we can able to select the region of interest area. So if I save the code, if I run the code, as you can see we can now select the region of interest area. So let's say this is what our region of interest area. Okay, so we need to simply draw the rectangle. Let me, okay, this is our, so this is what our region of interest area. So we need to select the coordinates. Okay, so simply top left, if I move the cursor on the frame, as you can see there is a x and y values. Okay, so we need to go here top left. If I move the cursor on top left of our rectangle, we will have the x and y coordinates. So x is 71 and y is 208. So we need to mention here 71 and 208. That's it. Now we need another coordinates, which is the bottom right. So bottom right we need to mention x and y. So x is 506 and y is 330. 506 and 330. So we are going to mention 506 and 330. That's it. We have the coordinates. Save the code, stop the ROI, and now we don't want the ROI function, so I'm going to comment it, not comment out. Okay, so comment it, all these things. And what we are going to do, we are going to mention these coordinates as a ROI. So after resizing frame, ROI is equal to, we are going to apply the ROI on our frame. So frame, inside that we need to mention these coordinates. So first 208 and 330. So 208, okay, like this way, 208 colon 330 comma 71 and 506. Okay, so this is what the format, 71 colon 506. That's it. We have now our region of interest area. Now what we are going to do, we are going to use here background subtractor mock 2. Okay, so simply here we need to mention obj. Let's call obj, this is just a variable, you can call any. Okay, so obj is equal to cv2 dot create background subtractor. Okay, subtractor. Okay, background subtractor mock 2, and inside that we need to pass some coordinates. So history, let's say 100, and we need to mention var threshold. Var threshold is equal to 70. Okay, so CV2 create background subtractor mock 2, history is equal to 100 and var threshold is equal to 70. That's it. So we have now our object. So our object is basically background subtractor. It will subtract the background. Okay, so now after ROI we are going to call our object. So let's say mask is equal to obj, this is what our variable, obj dot apply. We are going to apply our background subtractor on our region of interest area, means on our ROI. So we need to mention ROI. That's it. So what I'm going to do, just a minute, like this way. So here we are going to change the frame with the mask, then we will get the idea. Okay, so if I save the code and if I run the code, as you can see the background subtractor. Okay, we will have now the cars. The cars is basically in white pixels. Okay, we can say in white color. Okay, so now what we are going to do, we are going to use here threshold. Okay, so after mask, first channel empty, then after that comma mask. Okay, first channel empty, then mask. We are going to use CV2 dot threshold. CV2 dot threshold, we need to pass our mask. Okay, then 254 and 255. Okay, then method we are going to use CV2 dot thresh binary. Okay, CV2 dot thresh binary, this is the method which we are going to use. Okay, so we have now our threshold. Now we are going to find the contours. Okay, so simply what we are going to do here, we are going to, let's say, contour CNT, second channel empty, is equal to CV2 dot find contours. Okay, find contours. It will find the contours from our mask. Okay, so we need to mention the mask, then we need to pass the parameters, which is CV2 dot return tree. Okay, then CV2 dot chain approx simple. That's it. CV2 dot chain approx simple. Now we have our contours. Now we are going to use the for loop. So for C in CNT, which is our contours. Okay, we need to find the contour area. So okay, so area is equal to CV2 dot contour, CV2 dot contours area. Okay, so contour area, and inside that we need to pass the C, because C is our contours. Okay, so area is equal to CV2 dot contour area. That's it. Now what we are going to do, we are going to say like this way: if area is greater than 400, then we are going to draw the contours. Okay, so if area is greater than 400, we are going to say like this way: CV2 dot draw contours, and then we are going to draw the contours on our region of interest area. So ROI, then our contours, which is the C -1, then we need to mention the color. Let's make it green and 0, then the thickness, let's make it 2. Okay, so if all is good, we will see the contours on our vehicle. okay, in a region of interest area also. Okay, so save the code, and if I, so let's just first change, of course we need to change the mask with the frame. Okay, otherwise it will show us the mask frame, the black frame, black and white frame. Okay, so we need to change our original frame. So frame, and run the code. As you can see, it's detected the contour on our, in basically our region of interest area, where we select our region of interest area. Okay, here as you can see, so we have now our contours. Now what we are going to do, with the help of cv2.bounding rectangle, we will get the x, y, w, h coordinates, and then we can draw the rectangle. Okay, so now we don't want to draw our contours, because we know that we have the contour. So simply I am going to comment the contour, cv2.contour, and we are going to use cv2.bounding rect method. So here, if area 400, if area is greater than 400, then we are going to say x, y, w, h is equal to cv2.bounding rect, and we need to pass our c. C is basically our contours. Okay, so x, y, w, h, cv2.bounding rect, then simple cv2.rectangle, and we are going to draw the rectangle of on our region of interest area. So ROI, then x, y, x plus w, x plus width, then y plus h means y plus height. Okay, then we are going to make the color. So let's make it 00255 red, and then the thickness, let's make it 2. Okay, so if I save the code, if I run the code, and as you can see, we have the rectangle on our vehicle. Here it is, as you can see, the red rectangle. When the vehicle comes in our region of interest area, where we select our ROI, we have the rectangle on our vehicle. Okay, so basically we successfully detect our object, our vehicle. Now we want to track the vehicle. Okay, so simply I am going to stop the code. So for tracking vehicle, we have tracker.py. Okay, so we have already tracker.py file inside our opencv object tracking bullseye folder. As you can see, we want to simply call this tracker inside our main.py. So let's call it. So let's say after import cv2, we are going to say like this way, from tracker, this is what our file name, tracker. From tracker, we are going to import all the things from our tracker file. So for that, we need to mention import star. So it will import all the things from our tracker file. Okay, then after obj, we need to call the tracker. Okay, so tracker as an object. So tracker is equal to, the class is tracker and the T is capital. So T capital tracker, like this way. Okay, so tracker is the object, or we can say the variable. So tracker is equal to our tracker class, which we have inside the tracker.py. So tracker. Okay, so now what we want to do, we want to save our x, y, w, h coordinate inside the list. So instead drawing the rectangle, we don't want to draw the rectangle right now. We want to save our x, y, w, h coordinates, or we want to save our rectangles inside the list. So I am going to comment, or let's remove it. Okay, let's just remove it, because we don't want to draw a rectangle here. We are going to save the x, y, w, h coordinates inside the list. We are going to pass the rectangles in our tracker, and then tracker will get us the ID and the x, y, w, h coordinates. Okay, so first we need to create the empty list. After here, let's say what we can call it, let's say points. Points is equal to, this is what our empty list, points, and here we are going to say points dot append, points dot append, and we need to pass our x, y, W and H, X, Y, W, H. That's it. So now we have the points inside our points list. Now here we are going to say like this way. Let's say point. Again we are going to say as a point is equal to tracker. We have our tracker. Okay, this is what tracker. So tracker dot update, and inside that we need to pass our points list. Okay, so point is equal to tracker dot update. We need to pass the list points. Okay, then we are going to use a for loop. So for I in point, if I print the I, okay, now simply save the code, and if I run the code, something problem, let me check. Okay, update points, what is the problem? Point tracker dot updates points. Oh, so there is a indentation level problem. Okay, so we need to make like this way. Now it's in level. Okay, so for is also come back. Okay, so all is good. If I save the code, if I run the code, now if you see, we have ID, the 3, then 3, and we have also X, Y, W, H coordinates. So we have ID and we have X, Y, W, H coordinates. Okay, simple. Now what we are going to do, we are going to, because we have the X, Y, W, H coordinates, as I told you, now we can draw the rectangles with the ID. Okay, so remove the print, and we are going to mention like this way: X, Y, W, H, and the ID, because we have ID. As you can see, this 9 and 10 is basically the ID for particular vehicle. Okay, so X, Y, W, H and the ID is equal to I. That's it. Now we can draw the rectangle. So CV2 dot rectangle, and we are going to draw the rectangle on our region of interest area. So ROI, then X, Y, X plus width, Y plus height. Okay, then 00255 red color, and thickness, let's make it 2. Okay, so if I save the code, if I run the code, as you can see, we have the rectangles on our vehicles. Okay, so now we need to put the text, and we are going to put our tracker ID on the rectangle. Okay, so cv2 dot put text, cv2 dot put text like this way, and inside that again we are going to put text on our region of interest area. So ROI, and then we need to pass the ID. So str inside that ID. Okay, our ID, this is what our ID variable, so we need to pass the ID. This is what our text. Okay, so ID, then the coordinates X, Y space -1. Okay, then we need to mention the font. So cv2 dot font Harshe, let's make it complex, font Harshe complex. This is what the font name. Then let's make it 1 and 0 slash, let's make it blue. Okay, 25500, and the thickness we are going to make 2. That's it. So if I save the code and if I run the code, as you can see, we have now IDs on our vehicle. So basically we can say we can now basically track the vehicle with ID. Okay, so this is how, friends, you can use the background subtractor. Also you can use the tracker for tracking the object. Okay, so I hope you would learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.